The next presentation is by Dr. Barnali Das. There's a slight change in the topic that she would like to present today. I request her to name the change and then tell us about that.
A very good morning, all of you. Today my presentation I have changed because I think beyond accreditation, and we are talking about NABL accreditation in next session also. We are talking with the NABL directors and NABH directors. And so my topic today is beyond accreditation, the standardization and harmonization. Because as a committee member for standardization committee for thyroid function test, I want to emphasize on the how harmonization and standardization is. So this is as a IFCC standardization committee for thyroid function test and also for IFCC reference interval and decision limit committee. So this is our publications in IFCC, and this is in some Times of India first page report. And so why this is important? Like if you see this TSH report of 3 different labs, again yesterday I spoken about HbA1c. So similarly you will see there are difference in the TSH report from 3 or 4 different labs. So then they go to the thyroid specialist or endocrinologist, and endocrinologist is thinking why there is so much difference. Because a lot of time our clinicians are calling us, like we have done from our hospital and the report of TSH is this, but when they have done to another hospital like Hinduja or Lilavati, the TSH report is it can vary from normal to abnormal, or like FT3, yesterday we got a WhatsApp report in one group, like FT3, FT4 normal, but TSH is highly abnormal. So why there is this difference? So, and if you see today's lab system, patients are coming with burden of disease, and then we are using our intelligence, creativity, and discipline, and patients are going with reports. Either they are happy or they are concerned about wrong reporting. So this is very important, and when we go as a NABL assessor or CAP inspector, we do sample audits. So sometimes we are very much ignore the facts that there is difference in the opinion. I'll share one example for my NABL assessment. One lab I have gone, they have one instrument and one backup instrument, but there was no method comparison, and the validation or verification study was not done. So I have given the non-compliance, and then they have done the proper validation or verification study. So, and they submitted, and I have closed that non-compliance. And when it went to the technical committee has written because our value was not more than, this was for thyroid function test for TSH, as our value was not more than, it was less than 0.95. So how you have accepted as a assessor, how you have closed that non-compliance? So then I have to challenge the NABL technical committee that what you are saying, that's incorrect, because TSH we have seen there can be 40% difference or 40% variation between method to method, or between different analyzer. So sometimes it's very important to understand our test, and sometimes if required, we need to challenge the expert. So what do you think? Why there is so much variation? Do you think because in India samples are transported in different type of transport? Like yesterday Mr. Relia was speaking, they are collection center, technical committee they are going to form. So, and this is very important, the collection center. So do you think sample integrity is an issue for the TSH or thyroid function test? How many of you think that? So let's see why there is a difference. So the enigma behind the thyroid function test, like thyroid gland together with the pituitary and hypothalamus, this forms a well-orchestrated triad. So that this forms like mini orchestra. So we need to it's maintaining the hormonal and biochemical symphony in our body. So the functioning of this very important gland has come into question, is thrown up new mysteries. Because the first problem is the normal or acceptable range upper or lower limits of thyroid function test in particular population debated in different scientific fora. Like what we are using, that is given for that different, like, you know, American population or the European population. And we are using that for Indian population. So this is like, you know, what may be the Indian population upper limits and lower limits, that is completely different than the what we are using according to the pack insert. Second is standardization is still formidable challenge due to lack of proper reference intervals. And the clinician and diagnostician have to grapple with the variability of test results, because there are maybe 40% more or less TSH value. Like one single report from 2 different labs by 2 different methods can give 40% variation. And the variation can be to the extent that each individual can seem to have their own set point of these hormones. So why these types of variation? Because TSH has like physiological TSH variability, methodological TSH variability, heterophilic antibodies like HAMA, TSH autoantibodies or macro TSH, antibodies targeting a reagent used in the assay like ruthenium antibodies, and there are different technical causes or pathophysiologic causes. So our committee for standardization of thyroid reference interval is formed. IFCC, it was working group, now it is a committee, 6-member committee worldwide. This is to develop the reference measurement system for free thyroid hormones and TSH, to establish the network of lab competent to offer the reference measurement services for thyroid hormones worldwide, and to define the reference interval for different population. So we are like the 6-member team, like Linda Thinpont from Belgium is the chair, Jim Fay is from Stanford, me, Finlay, and Rotman, they are from the different manufacturer. So our study, this 2015, it was published in European Thyroid Journal, and recently it is getting published in Clinical Biochemistry, and the last study was in 2010 in Clinical Chemistry, the phase 2 study. Sorry, phase 1 study. So what is the difference between standardization or harmonization? Standardization is like where there is a full meteorological traceability, where we have the primary reference measurement procedure and the secondary reference measurement procedure, then standardization is possible. And when we don't have primary reference measurement procedure or secondary reference measurement procedure, then standardization is not possible. Then we need to do the harmonization. So harmonization is partial meteorological traceability. So if you see standardization, there is a primary reference measurement procedure. For harmonization, there is no primary reference measurement procedure or secondary reference measurement procedure. For T3 to T4, total T3, total T4, the standardization is possible, but for TSH, we don't have any primary reference measurement procedure. For TSH, standardization is not possible. For TSH, we need to harmonize our test. Because TSH is a complex glycoprotein, and there is no primary reference measurement procedure, so then we need to solve this by all-purpose streamed means from all the manufacturers. So this is our phase 1 study, like 40 samples from 16 different immunoassay. So we have completed till phase 3, so now the phase 4 trials have been started. So if you can see in phase 3 trials, this is from 16 different manufacturers. So this is before calibration, and after master calibrator we have supplied. So you can see the difference. So there was so much difference before calibration, and after calibration you can see the difference is so less. So coming to what as a chemical pathologist or what as a biochemist or as a pathologist we can do, we are sitting in a small size lab or we are sitting in a medium size lab or big size lab, what we can do. Because sometimes, you know, to get through the IFCC reference measurement procedure or to get through their technical committee is not possible. So what in our small lab we can do? So this is the experience, like, you know, when we go for the assessment. So we ask for the verification study or validation study. So you can see this lab director, they have all the document in, you know, available. They have done multiple studies, the data are available, but they don't really know which data to show as a verification protocol. And if you can see, this is another lab. So they have, like, you know, striving for accuracy and precision. So the verification protocol, analytical accuracy according to CLSI EP 15A2 guidelines, we can run samples by both new method and comparative method. For that, we need minimum 20 samples. Verification of precision, analyze repeatedly at all levels of control sera, run 3 times per run for 5 days, that is 15 replicates. For checking the reference interval, it's not possible. I'm sitting in a small size lab. It's not possible to verify all my 350 analytes. So then at least we need to verify our reference interval. For that, we need minimum, according to CLSI C28 guidelines, we need minimum 20 represented healthy individuals. And coming to the verification of analytical sensitivity, we run 20 blanks or zero calibrator or low patient samples. If less than 3 exceeds stated blank value, we accept that value. So now coming to the reportable range. There are 2 types of reportable range, like analytical measurement range and clinically reportable range. Analytical measurement range can be reported without dilution or pre-treatment, and clinically reportable range is with dilution and pre-treatment, what value we are giving. So this is like many of us are, yesterday I have met, many of us are from the big reference lab. So if you see, if you discuss with your clinical biochemist, they like take the example of tumor marker. They are giving tumor marker or estradiol. They are giving the values in lakhs. Do you feel that is correct? We know that's not correct, but we are giving the values, like, you know, to maintain our market. So this is, we should define our analytical measurement range and CRR, because manufacturer clearly mentions that beyond that, we should not extend our CRR. So then, but our oncologist said we should be restricted, like we should give the proper value. If it is coming in lakhs, they say that we don't care, you give me the exact value. I don't want more than 10,000. So, and we go with the oncologist or clinician and we give the, like, you know, the CEA values in lakhs. So, but we are giving incorrect results. We are hearing our clinician friends and we are giving incorrect results. So then we have to, like, implement, so what should be our AMR and what should be our CRR, and we have to tell that beyond that we should not report. And if you know, we will go do the dilution, like some labs, like big labs, they can't like lose their this thing, clinician. So they verbally you report, because tomorrow there can be legal implication for that. So this is like reference interval. So I have already told that, like, we need 20 healthy individuals, and if more than 22 samples outside, we have to repeat that in 20 more individuals. And suppose we want to establish reference interval, FDA says that you need 600 population, but for a lab, like small lab or medium-sized lab, if they need to, like for some new analytes, they need to establish their reference interval. If this is following Gaussian distribution, you can take 120 individual. Suppose this is not following Gaussian distribution, you need minimum 200 individuals. So this is our study design. We have taken 800 healthy subjects for TSH. So these are the inclusion criteria and exclusion criteria for TSH reference interval. This is very important because in our hospital or in our lab, maximum people do the reference interval study from the executive health checkup, and they think that executives are all normal and healthy. We don't care about, you know, our exclusion and inclusion criteria. So to have the reference interval study, we need to define our exclusion and inclusion criteria. So this is our reference interval study. If you can see the difference, like this is around 0.49 to 4.67 for TSH, and this is the manufacturer suggested range. So you can see the difference for the Indian population study. So analytical accuracy is done mainly two ways. Like I have said, with 20 samples, we can do method verification. And according to CLSI EP982, like we need minimum 40 samples by both new method and comparative method. This is for all the new tests. Suppose there is a new test for HbA1c, they have newly launched, then you need to do this study. Otherwise, if you go with the 20 samples, that's fine. So this is our method comparison study between two different same manufacturer with two different instrument. And here the R value, if it is more than 0.975, we accept. And we have to plot the bias plot and see the difference. So coming to the precisions, this is again another lab example. I have gone to, like for NABL assessment, we need to do the retesting and witness testing. So when I have gone to this lab, this is the autoimmune lab or immunofluorescence microscopy lab, and this is the biochemistry lab. So as a protocol of retesting, so I have given here for retesting of certain analytes from biochemistry parameters, and this is for retesting of the autoimmune. And this gentleman biochemist has given me the reports in few minutes, few hours of time. Until closing meeting in IFA lab, they were not able to submit me the cell lines. So then when I asked, the lab director was my friend, what happened? So he shared with me the true story, like the technician who used to do the precision study, the IFA study or immunofluorescence microscopy, he has resigned. So because of that, the new technician has over-diluted it, and because of that, you know, we can't see any cell lines in immunofluorescence microscopy. So this is called precision or reproducibility. So precision can be two types, like repeatability or within run precision and within lab precision. So this we can do by, like I have already said, 3 replicate samples at each of 2 concentration for 5 days. That is 15 replicates in all. So this is our precision study. So we need to calculate sigma R and verification value. If SR less than sigma R or verification value, then we accept the precision study. So then this is the analytical sensitivity experiment. For that, we have done like 20 blanks or low level of samples or 0 calibrators. If less than 3 exceeds stated blank value, we accept that. So coming to the sigma-metric analysis for the TSH. So sigma-metric is total allowable error minus bias divided by CV. So if you can see, this is the true value, and this is the distribution, this is bias, and this is the location, this is CV. And this is defects per million opportunities. So suppose we are at 6 sigma level, so defects per million opportunity is 3.4 defects per million opportunities. So the tail is depicted by defects or sigma. So this is our sigma matrix chart. So sigma matrix chart, if you see, so this y-axis say that probability of rejection, and x-axis says systematic error. So and this vertical lines, these are different sigmas, like 3 sigma, 4 sigma, and 5 sigma, and 6 sigma. And key at the right, like what QC rules we should follow. Because why there is importance to use sigma matrix, we can implement our QC rule or waistguard rule according to our sigma matrix study. So like if PFR is probability of false rejection and PED is probability of error detection. So suppose we are at this analyze at less than 4 sigma levels. So you see we need to use all the waistguard multi-rules with n is equal to 6 or n is equal to maximum. But if our analyze is at more than 6 sigma, then we can use 3S rule with n is equal to 2. So according to sigma matrix, we can decide our QC protocol, or we can individualize our quality control program. And this is our sigma matrix display of method decision chart. So this is MEDEX chart. This is the bullseye. If we are at 6 sigma, we are world class. If we are at 3 sigma, then we need to do improve our process excellence. See the sigma matrix study for thyroid stimulating hormone. If you can see, like in 2011 when we started, we were at 4.25 sigma level, and in 2015 March, it was we have achieved till 9 sigma level. So by just improving our process, we can implement the QC rule, and if we implement the QC rule according to the sigma matrix, so they have suggested our existing rule was like 1 through 3S, 2 2S, and R4S, and 10x rules. But they have suggested you can use 1 3S rule with n is equal to 2. So according to, we can individualize our QC programs, and according to that, there can be cost effective our QC program, and we can conceptualize and individualize our quality control plan. So this is for other tests. This is for, like I have already said, the difference between standardization and harmonization. So like electrolytes, glucose, and enzymes, the standardization is possible because there is a primary reference measurement procedure. But for this test, like protein, tumor markers, and all, standardization is not possible because there is no primary reference measurement procedure. So we need to harmonize the test. So thank you very much. I want to say again, with Robert Frost, we have taken baby steps, but there are miles to go. Thank you very much.
Any questions?
That was a wonderful presentation, Dr. Barnali. And this is not exactly a question, it's a comment with reference to TSH. In fact, the problems related to TSH assay, the analytical part you have very well highlighted. But in our experience itself, I would like to just highlight, I'm sure most of you face the same problem. The problem with TSH assay extends even to the pre-examination and the post-examination. First of all, the people who ask for these tests should realize that asking for TSH alone has no value. It should always be clubbed with either a free T4 or a T3 T4 if the free T4 is not available. But out of 10 requests for thyroid tests, at least 4 or 5 will be TSH alone. Now, what is the laboratory's responsibility? Are we accepting it and releasing reports without any explanatory notes? Or do we say we will not accept TSH requests alone? That is one aspect of pre. And second is, we do not know whether the patient is already on treatment. And that again adds another complexity to the situation. And then comes the post. Now with a single marginally elevated TSH reading, patients are put on treatment, and then they come back week or 10 days later, the values have dropped to normal or lower normal ranges, and then they say, my doctor says it's impossible for a TSH value to come down within 10 days. So there are a lot of problems. Now we face these day in and day out. I'm sure all of you face these. So what do we need to take? What do we need to do? Adding this additional information in our reports to explain, improve the knowledge of the patients, to improve the knowledge of the clinicians. Because every clinician feels he's an endocrinologist who is competent to treat thyroid diseases.
Pre-analytical and post-analytical phase for all those complex analytes, like for TSH, like where, the standardization is really a challenge. Like we were not able to do the standardization. And another thing is, I have not mentioned the pregnancy. Like they not mention pregnancy, they are pregnant and the endocrinologists or clinicians are sending samples, but it's completely different. So, and that notes is very important, and we as a diagnostician, it's our duty, we should be very careful, and we should actually, should tell the clinicians that exactly I want.
But another lab which is a very renowned lab, and it is continuously coming normal. So how do we explain to the patient about these kind of, like, it is very difficult to explain to the patients. Yes. Yeah, so then it becomes, they don't understand that pre-analytical or analytical. Okay, thank you.
Thank you, Dr. Barnali. I request the chairperson to please hand over the memento and the certificate to Dr. Barnali. Thank you, sir. Thank you, ma'am.